Hello and welcome back to another video. In this problem, we're told that anthropologists use a linear model that relates human femur, thigh bone length to height. The model allows an anthropologist to determine the height of an individual when only a partial skeleton, including the femur, is found. Here we find the model by analyzing the data on femur length and height for the 8 males given in the following table. First, in A, we're asked to make a scatter plot of the data. So the X values are ranging from 38 to 50, and the Y values are ranging from 155 to 178. So in both of these cases, I don't think it makes sense to start from 0. So on the X-axis, we're going to start at 38, and on the Y-axis, we're going to start from 155. And this is height, this is femur length. We're going to go up to the maximum height, 50, the maximum length, 50, and the maximum height, we can go up to 180. So, starting us off, we have a 38 right here and 155.8 right there. Next, 39.5 can be right here. 155.4 is almost the same exact thing, just a bit above 155. Next, 42.7, it's going to jump up quite a bit, up to 165. 44.5 is going to be 168.3. 44.7, slightly more, but starts to dip again, below both of these points, before going up slightly for 45.2. 48.3, way over here, is all the way up at 173.6. And 50.1, just above this line, is at 178.5. So we have all these points here. It doesn't have to be exactly accurate, just has to be close. And we find the LSRL, the least square regressions line. A couple ways you can do it online. You can do it with a graphing calculator. And it reduces the distance from all of these points to any given line. The smallest one becomes the LSRL. Y equals 1.88x plus 82.65. Right, this is roughly what it is. This is the regression line, and the easiest way to graph this line is to not worry about the y-intercept and the slope, especially when you're not dealing with the real y-axis, right? We're starting at 38. The easiest way is to fit a line that goes as close to possible, as you can see, with all the points. Alternatively, you could pick 2 points, but you're going to get the exact same graph on a hand-drawn graph, right? It's just not accurate enough to see slight differentiations in the regression line. An anthropologist finds a human femur length of 53 centimeters. How tall was the person? Well, based off of our model, we would expect y equals 1.88 times 53 plus 82.65 would be the expected, right? Not the actual, but the expected height of the person. So I don't love the way this is phrased, but the expected height by doing this calculation is roughly 182.33. Centimeters tall is the height for someone with a femur length of 53 based off of this line, which is attempting to model this relationship between femur length and height in humans.